In this problem, we're asked to calculate the equilibrium concentration of carbon monoxide. We're going to use our value of K and our equilibrium concentrations here, and we're also going to be using this balanced chemical equation to write our equilibrium constant expression. And here's our equilibrium constant expression. As always, we have the concentration of our products raised to their coefficients. Here the coefficient of C4H10 is 1, and the coefficient associated with H2O is 4. Our denominator contains the equilibrium concentrations of our reactants raised to their coefficients. Carbon monoxide has a coefficient of 4, and H2 has a coefficient of 9. So this is our equilibrium constant expression. The problem is asking us to calculate the equilibrium concentration of CO. So initially we're going to solve this expression for the equilibrium concentration of CO raised to the 4th power. We've gone through the algebraic steps to solve for the equilibrium concentration of CO raised to the 4th power. The next step is to solve for the equilibrium concentration of carbon monoxide by taking the 4th root of each side of this expression. Alright, so here are our numerical values substituted in from this problem statement. We're going to evaluate this using our calculator, and we get 7.76185. We're going to raise that to the 1/4 power and get this number, which to 2 sig figs is 0.017 moles per liter, our final answer.